Okay, and here we go. Now I'm going to continue this reading because I'm going to discuss, because of what I said about leap years, I said I want to go into the science of the leap year and see if I'm correct, and also to just do some comparisons with the scriptural discussion of a ancient 364-day year. Okay, where we're talking 50 million years ago. So you're talking a long time ago, okay? A leap year, also known as an intercalary year or bisextile year, is a calendar year that contains an additional day, or in the case of a lunisolar calendar, a month added to keep the calendar year synchronized with the astronomical year of seasonal year. Because astronomical events and seasons do not repeat in a whole number of days, calendars that have a constant number of days in each year will unavoidably drift over time with respect to the event that the year is supposed to track, such as seasons, by inserting, called intercalating in technical terminology, an additional day or month into some years. The drift between a civilization's dating system and the physical properties of the solar system can be corrected. A year that is not a leap year is a common year. For example, in the Gregorian calendar, each leap year has 366 days instead of 365, by extending February to 29 days rather than the common 28. So once again, what we see here, if I'm correct, is that, wait a minute, let me finish yet. These extra days occur in each year, which is an integer multiple of 4, except for years if evenly divisible by 100, but not by 400. The leap year of 366 days has 52 weeks and 2 days. Hence, the year following a leap year will start later by 2 days of the week. So once again, this tells me this, that for whatever combination of a wider orbit, shorter orbit, faster or slower, our planet takes a minimum of 1 day longer every year to circle the sun in one complete orbit than it did in the beginning of the creation, according to the book of Enoch, okay, which was a set 364-day year. So once again, my thought would be something as cataclysmic as even an atomic bomb or some sort of explosion could possibly knock the planet not only further out from its orbit by a little bit or closer, but also could slow its orbit, slow its movement. That's all it takes, okay? So we don't know, but it's possible that that may have been the issue, you know? Also, how do I know that from the beginning of creation it's not natural that it just would slow down anyway, right? It may just slow down anyway. So these are things we don't know. So it may not have taken any sort of cataclysmic event for that to occur. It may just be something over 50 million years that the planet simply slowed down. Or maybe it actually moved out from orbit a little bit. I don't know. Or maybe it moved in closer and slowed down even more. But for whatever reason, with the two factors that will make a change, at least these two factors, and even more unknown, of the distance of the Earth from the Sun changing in terms of farther or closer, and its speed in moving around the Sun faster or slower, for whatever reason, in those at least two factors, our planet overall takes longer to orbit the Sun in one complete year. Okay, this we can conclude for reasons known and unknown. Okay, I'm going to stop the broadcast and continue.